Before the James Webb Space Telescope even began its scientific mission, expectations were almost impossible to meet. For more than 3 decades, the Hubble Space Telescope had transformed our understanding of the universe. It revealed galaxies billions of light-years away, captured the birth of stars, helped discover that planets orbit almost every type of star. Many wondered, could any telescope really surpass Hubble? Then came July 2022. The world stopped to look at a single image. At first glance, it didn't seem extraordinary, just a patch of black space filled with countless tiny points of light. But what people were actually looking at was one of the deepest and most important images ever captured by humanity. The very first full-color image released by the James Webb Space Telescope. And it changed astronomy overnight. The target was a galaxy cluster known as SMACS 0723, located about 4.6 billion light-years from Earth. On its own, the cluster is already impressive. It contains enormous galaxies, each holding hundreds of billions of stars. But those galaxies weren't the real reason Webb pointed its mirrors in that direction. They were being used as something else. A natural telescope. According to Einstein's theory of general relativity, mass bends space itself. When light from a much more distant galaxy passes near a massive object, its path curves. The galaxy's light becomes stretched, magnified, sometimes even duplicated. Astronomers call this effect gravitational lensing. It's nature's own magnifying glass. SMACS 0723 acts like an enormous cosmic lens. Behind it lie galaxies so distant that, without this effect, they would be far too faint for us to see. Combined with James Webb's extraordinary sensitivity, the result was breathtaking. Thousands of galaxies appeared in a region of sky no larger than holding a grain of sand at arm's length. Think about that. Cover the tip of your finger against the night sky. The tiny area hidden behind it contains thousands of galaxies. Each galaxy contains billions, or even trillions, of stars. Each star may have planets. Some may have entire solar systems unlike anything we've ever imagined. What looked like empty darkness was actually overflowing with cosmic history. But perhaps the most astonishing detail wasn't the number of galaxies. It was their age. Some of the faintest galaxies visible in Webb's image emitted their light more than 13 billion years ago. The universe itself is about 13.8 billion years old. That means the light entering Webb's mirrors began its journey when the very first galaxies were forming. Before Earth existed. Before the Sun was born. Before our solar system even began to take shape. Looking at this image isn't simply looking across space. It's looking back through time. Every galaxy appears exactly as it was billions of years ago. Some are young and chaotic. Others are already surprisingly well organized. Their shapes immediately caught astronomers' attention. According to many theories, the earliest galaxies should have been small, irregular collections of stars. Yet Webb was revealing systems that seemed larger, brighter, and more mature than expected. Almost immediately, scientists realized something remarkable. The early universe may have evolved much faster than existing models predicted. Suddenly, one image had raised entirely new questions about the history of the cosmos. And that was only the beginning. Because hidden inside this extraordinary photograph were details that astronomers would spend months analyzing. Clues that could completely reshape our understanding of how the first galaxies were born. As astronomers zoomed in on Webb's first image, the surprises only became greater. What looked like tiny specks of light were actually entire galaxies, each one containing hundreds of billions of stars. Some were elegant spirals similar to our own Milky Way. Others were distorted into glowing arcs by the immense gravity of the galaxy cluster in the foreground. But hidden among them were galaxies that shouldn't have existed. At least, not according to many of our best models. The early universe was supposed to be a simple place. After the Big Bang, matter slowly gathered under the influence of gravity. Small galaxies formed first. Over billions of years, they merged together to create the massive galaxies we see today. That was the accepted picture. Then James Webb looked deeper than ever before. Instead of finding only small, primitive galaxies, it revealed surprisingly bright and massive systems existing just a few 100 million years after the Big Bang. Some appeared to contain enormous numbers of stars. Others showed surprisingly organized structures. It was as if parts of the universe had grown up far faster than expected. Naturally, astronomers were cautious. Extraordinary discoveries require extraordinary evidence. Could the distances be wrong? Were the galaxies actually closer than they appeared? Or were scientists seeing something completely new? Over the following months, Powerful spectroscopic observations confirmed that many of these galaxies really were incredibly ancient. The universe, it seemed, had become complex much earlier than anyone anticipated. That single image had opened an entirely new chapter in cosmology. But Webb wasn't finished. Unlike Hubble, which primarily observes visible light, James Webb is designed to detect infrared light. Why does that matter? Because as the universe expands, the light from distant galaxies stretches. Visible light gradually shifts into infrared wavelengths. By the time it reaches Earth, much of it is completely invisible to our eyes. To older telescopes, those galaxies were simply too faint to detect. But to James Webb, they suddenly appeared in extraordinary detail. It was like putting on a pair of glasses for the first time. Objects that had always been there, but hidden from view, finally became visible. Scientists also noticed something remarkable about the galaxies themselves. Many contain large amounts of dust. Normally, dust blocks visible light, hiding newborn stars behind thick cosmic clouds. But infrared light passes through much of that dust. For the first time, astronomers could peer into regions where stars were actively forming. Entire stellar nurseries emerged from the darkness. It wasn't just a better picture. It was a completely different way of seeing the universe. Then came one of the image's most fascinating discoveries. The gravitational lens created by SMACS 0723 wasn't merely producing beautiful distortions. It was acting like a natural telescope, magnifying galaxies that would otherwise remain forever beyond our reach. Some were amplified by factors of 10, 20, or even more. Without the galaxy cluster's gravity, humanity might not have seen them for decades. Nature itself had provided James Webb with an enormous cosmic zoom lens. And every curved arc of light contained valuable information. By measuring exactly how those arcs were distorted, scientists could map the invisible dark matter surrounding the galaxy cluster. Dark matter emits no light. It cannot be photographed directly. Yet its gravity bends space itself. Webb's first image wasn't just showing galaxies. It was revealing the hidden architecture of the universe. An invisible framework holding everything together. And the deeper astronomers looked into that remarkable photograph, the more they realized that it contained far more than a beautiful view of space. It contained clues that could change our understanding of how the entire universe came to be. And perhaps that's what made James Webb's first image so unforgettable. It wasn't simply beautiful. It was historic. For the first time, humanity was seeing the universe with a level of clarity that had never been possible before. That single image represented more than 20 years of planning, thousands of engineers, hundreds of scientists, and one of the most ambitious space missions ever attempted. When Webb unfolded perfectly in space after its launch, many called it an engineering miracle. Its gold-coated mirror, stretching 6.5 meters across, became the largest mirror ever sent beyond Earth. Positioned nearly 1.5 million kilometers away at the second Lagrange point, or L2, Webb operates in one of the coldest environments possible. Protected by a sunshield the size of a tennis court, the telescope remains cold enough to detect the faint infrared light that has traveled across the universe for billions of years. Without those extreme conditions, its discoveries would be impossible. But perhaps the greatest achievement of that first image wasn't what it answered. It was what it questioned. Why did some galaxies become so massive so quickly? How could stars have formed at such incredible rates only a few 100 million years after the Big Bang? Are our current models of galaxy formation incomplete? Or is there physics we still don't understand? These are the kinds of questions that drive astronomy forward. Every time humanity builds a more powerful telescope, the universe surprises us. Galileo revealed moons orbiting Jupiter. Hubble showed us that the universe extends far beyond the Milky Way. The Hubble Space Telescope uncovered dark energy in countless distant galaxies. Now, James Webb is rewriting the story once again. Since that first image was released, Webb has gone on to study the atmospheres of distant exoplanets, photograph dying stars, peer inside stellar nurseries, and identify some of the earliest known galaxies in cosmic history. Each observation adds another piece to the puzzle. And perhaps the most exciting discovery hasn't happened yet. Somewhere among the billions of galaxies Webb will observe over the coming years, there may be evidence of the very first generation of stars, the first black holes, or entirely new phenomena that no scientist has ever predicted. History suggests that the greatest discoveries are often the ones we weren't looking for. That's the beauty of exploration. You don't know exactly what you'll find. You simply look farther than anyone has looked before. And James Webb is doing exactly that. Imagine this. The light from some of the galaxies in Webb's first image began its journey toward Earth over 13 billion years ago, before the Sun existed, before Earth formed, before there was life, before there were humans to wonder what lay beyond the night sky. That ancient light traveled across an expanding universe, passing countless galaxies, crossing unimaginable distances, until it finally reached a telescope built by a civilization on a small blue planet. And in that moment, the universe shared another one of its secrets. Perhaps that's the most inspiring part of all. Every discovery reminds us how small we are, but it also reminds us how extraordinary human curiosity can be. From a species that once feared the darkness, to one capable of observing the birth of galaxies billions of light years away, we've come farther than anyone could have imagined. And our journey is only beginning. So the next time you see that famous first James Webb image, remember that you're not just looking at a beautiful picture. You're looking at one of the deepest glimpses into the history of the universe ever captured. A photograph that stunned the world, not because of what it showed, but because of what it revealed was still waiting to be discovered. If you enjoyed this video, don't forget to leave a like, subscribe to the channel, and turn on notifications so you never miss our next journey through the greatest mysteries of space. Because somewhere in the endless darkness, the next image from James Webb could change our understanding of the universe all over again.